Thank you, everyone, to join our session on Range on a Budget, building a cyber range from ground up to support academic education, research, and outreach. I know you made a choice to tune in to our session, so thank you for that. I know you had other great opportunities. We also want to thank NICE Conference for giving us time to speak at this conference. So first, I want to introduce myself and my colleagues and peers in this presentation. So my name is Ambareen Siraj, and I'm a professor of computer science at Tennessee Tech University. I also run our cybersecurity education research and outreach centers with our assistant director and cyber range technologist and two other folks. So I'm going to ask them to introduce themselves.
My name's Eric Brown. I am the assistant director for CEROC and work with Dr. Siraj and Travis on this project. And you will see a very interesting project before you, and a path that has taken over two to 3 years to actually develop. So I look forward to the opportunity to talking to everyone.
Hey everyone, so I'm Travis. I am the cybersecurity technologist at CEROC. I handle all of our cyber range infrastructure. I also am currently a student, and I started working on this project as an undergrad student before I got hired with CEROC. So.
But right now, Travis is a graduate student.
Yes, yes, I'm currently a grad student.
Part-time graduate student, but full-time, he's supporting our center. So next, please. So before we start, I just wanted to tell folks what we do at CEROC. Like other cyber centers that are out there, our mission is to increase awareness in this field, train students and faculty in cybersecurity, promoting and advancing research in important areas in cybersecurity, disseminate what we developed and share with the community, and in general be a resource for our region, our state, even nationally. Next, please. Just a couple of points about CEROC. We are not been existent for long. We started in 2016. We are a center of academic excellence, like many of you here. And we are out of four-year universities in Tennessee that have designation. We are one of them. We are the first and largest cyber core scholarship program in state of Tennessee. There is actually another one at University of Tennessee, Chattanooga. And we were one of the 10 community college pathway SFS program. We are also now the only CISP, DoD CISP program in the state. We also have the longest running NSF Gen Cyber program in Tennessee. Currently, we are also partnered with DoD in 2 projects. One is creating community college pathway for cyber education for community college students. And we are part of the CEDI coalition, the Cybersecurity Education Diversity Initiative coalition to serve as a resource for minority serving institutions across the country. We are partnered with Department of Energy to provide free cybersecurity risk assessment for small businesses and utility companies. And we are also the founding organization for the Women in Cybersecurity Conference and the nonprofit organization. Next, please. But the most important thing about our center is that everything that we do, we have students right at the center of it. So all our education, research, and outreach initiatives, which we pay equal attention to, are heavily involve our students in some capacity. So we try to give a holistic experience to our cybersecurity students that are actually students of our computer science department. Next, please. So here today we are here to talk about the cyber range, and the reason we went for building our own cyber range was motivated by a couple of factors. One obvious factor was we didn't have money to buy a cyber range, which cost anywhere between $500,000 to $1 million. And also we didn't have donors that would give us that money to do that. And another factor is that the power of customization. So we wanted to do something that really works well with all the initiatives that we want to do in education, research, and outreach. So we wanted to have that capability of customization for ourselves. Another big factor is the cost of maintenance, because we want to continue doing this. We didn't want to go in an agreement with a service provider, because that also comes with a hefty cost. Next, please. So 3 years back, we decided to build our own cyber range from scratch, little bit at a time. So we wanted a isolated and contained environment to support all our initiatives in education, research, and outreach. Next, please. So obviously, the hardware, especially the equipment for it, would cost money. And the way we did it was whenever we would write any grant, we would put some part of it. So the whole cyber range as it is today, it's not supported by one grant, but through multiple different grants, bit by bit. And we also used some of our operational fund at CEROC to invest in the cyber range. Next, please. So I'm going to ask Travis to talk about the cyber range in general.
Yeah. So there are some core features that I feel like every cyber range should have. These are not isolated strictly to our particular cyber range. Some of the most important feature of a range in general should be that it's controlled or isolated. So we do this by controlling network traffic. I can shut it off and on. We can use containerization on top of just using virtual machines to better isolate specific environments. This is extremely important if you're working with malware or anything, malicious. Some of the other components aren't necessary, but for a good, solid foundation for scalability, these are definitely needed. So automated configuration, what does that mean? So automated configuration would mean standing up the infrastructure, so the virtual machines, the Docker containers, whatever you're standing up. That would also include the configuring those machines. So if you have a web server, for instance, you want the web server to be configured. That's also in that. Rapid project deployment, so that would include standing up the infrastructure. So each thing that I implement, each set of instances, I consider a project. So if I'm setting up a class, I'm going to use IT security as an example for probably most of this talk. So IT security, if I'm standing up that project, that's one single project with multiple instances. And with our cyber range, we can do that very rapidly. It's not a absolute necessity unless you are standing up multiple environments or a lot of instances. Just for reference, with IT security, I usually stand up about 30 instances. Some of them are, just in case something breaks, or if I need more for any reason, students join late, whatever. But I can do that very rapidly. Flexible and adaptable. So our range, this might not be the same for most ranges, but our range is very flexible in the sense that if we have an outreach program and we expect, let's call it 50 instances of a project, um, I can scale that up very fast. Usually with a couple clicks of my keyboard, I can turn that from 50 to 200 or to 55, whatever I want. I can scale down. Um, our range has also become very adaptable because of the way that we do configuration management, because of the way that we store our infrastructure. We can adapt to most situations and have a very long term set of projects. And then the scalability of ours, we can honestly, with scalability, we can kind of chuck more servers into a rack and scale up. Um, I mean, we could also scale down in the same sense, but I don't know why we'd want to. This doesn't have to be for everyone. If all you're using your cyber range for is a single class, you don't have to have all of these things. But this is something that we needed. Next, please. Is this the next one or was this the previous one? There we go. So some of the infrastructure that we have right now, it costs around $150,000 compared to similar quotes that we had gotten at $750,000. That's quite a cut. That was well within our budget. Currently, that's running. We've got 3 Dell PowerEdge servers. The actual amount of resources or the servers that you use will vary depending on your use case. We went with this because we have a very high use of the range, and currently we're sitting at 128 logical processors per node, and we're also sitting at 760 gigs of usable RAM, which RAM, if in a cyber range, RAM is the weakest link. In my opinion, I see RAM being used more than anything else. Storage, the biggest thing is you want enough storage and you want fast storage. That's why we went with SSD storage, and we went with quite a bit of it because we have a lot of big projects. That's the hardware. You can change that to your needs. It's not necessarily this is what you have to do to build a cyber range. There's no guide that has all the hardware specifications for a range. The software is where it gets interesting. So we're using a combination of ESXi, which would be, we're also using vSphere and vCenter. We use a custom in-house platform called Pterodactyl. And we also use the basis for Pterodactyl, which is Terraform and SaltStack. And I'll get into those in the next slide. So next slide, please. So Terraform. So Terraform is, if you're not familiar with it, you can store your infrastructure as code. You can program standing up virtual machines, standing up Docker containers, and base configurations of these systems. It's very portable, so we can store all of our infrastructure in GitLab. You can put it on a thumb drive. I mean, you can keep it anywhere. It's code. Hit next. There should be another thing pop up. So with Terraform, we can stand up the infrastructure, which would just be baseline virtual machines. So we have configured very basic machines that we don't have to have different machines for each project. I can have one Debian machine and one Debian machine only that I use as my base. And then we transform into SaltStack, where that takes care of all of our configuration management. The reason that we went with SaltStack is it had better features that we were looking for. It was a lot more powerful than Ansible and some other tools that are on the market. Ansible being one of the more competitive ones. You don't have to use SaltStack. You can use whatever configuration management system you want. You also don't have to use Terraform. But the reason that we went with SaltStack was it has a solid it is a solid configuration manager. A lot of very usable features. It's super programmable. And every single time I run SaltStack, I get the same result. So it's very reproducible. If I want to build a project and tear it down 10 times in a row, Terraform and SaltStack will build it the exact same way every single time. That is one of the things that should be an absolute necessity um, with the cyber range, because if you're doing, say, a class or outreach event, um, you want the exact same configuration, the exact same machines. You want all of that to be the same every single time. If you test it and then you go, live or stable, um, you don't want to be the guy saying, "Well, it worked on my machine," or "It worked, in testing." This is why we chose these two. Next, please. So this is where we're cooking with gas. So Pterodactyl is our in-house platform. It is a pseudo Terraform domain specific language. So it's pseudo Terraform because it's built on Terraform, but it's not Terraform. And it's domain specific because it only, as of right now, it's configured to only work with ESXi. Terraform itself is supposed to be a cloud agnostic tool. Terraform also has a lot of flaws, bugs. Well, not really bugs. It has a lot of flaws, and it has a lot of hard to use features. And it is somewhat feature lacking whenever you compare it to our in-house product. So Pterodactyl is extremely flexible in the sense that we can scale up a project or scale it down very, very rapidly. All it takes is one variable change. So I can change the number 20 to the number 10, and I can scale down from 20 instances to 10 instances with just changing a number and then hitting enter. Pterodactyl is also extremely powerful. There's a lot of features to it. We can control, we can manage environments. So with Terraform, mostly it just builds and destroys, and it does some management. Pterodactyl is also built using Bash, PowerCLI, and Python all together on top of Terraform. That way we can control snapshots. So if you want to snapshot an environment before students do something that might be destructive, or if it's an important lab and you want to be able to roll back, we can control that on a project level. You can control that on a VM level. You can do most of these things. You can do all of these things in PowerCLI, but this gives you more of a Terraform look at it. So the project that you built inside of the folder that you're in, that's all you're going to be able to manage with Pterodactyl. You're not going to have the opportunity to mess up, another project. The biggest thing about Pterodactyl versus Terraform, though, and this is the reason we built it, is it's simple. So with Terraform, for some of our projects, we might have thousands of lines of code. It's still a lot better than building everything by hand. It's still a lot better than just copying VMs over, because you get a more reproducible, consistent feel. But there's not a lot of really good functions for copying instances and renaming them and having their own network. That's why we built Pterodactyl. So with Pterodactyl, we can turn thousands of lines of code into 50 lines. And the reason that this does this is Pterodactyl creates Terraform code. We wrote a program that will write code for us based on the Pterodactyl code. Pterodactyl, just like Terraform, is extremely reproducible. I would say even more so. And the simplicity of it is just, it is the reason that we built it. We can build at scale. Pterodactyl is very fast. I can build 30 instances with 5 machines each, some of them being Windows, some of them being Ubuntu, some firewalls. I can build 30 instances of that project in roughly 8 minutes from start to finish. It is extremely fast. Next, please. So some of the use cases that we have that were spoken of before, we do a lot of informal education. We do a lot of formal education. We support research, and then we support a lot of outreach events. Next, please. So some of the formal education that we do, I'm not going to go through all of these. These are just some of the courses that we do. Some courses might have a lab that they use the range for. Classes like IT security, though, and ethical hacking and reverse engineering, they use the range pretty much the entire semester. IT security being the main one, they have a lab every single week that they use, so it is constantly being used by students. Um, we use this for these courses where it could be dangerous, uh, such as reverse engineering or ethical hacking. It could be dangerous not to have a sandboxed environment to do these things in. With reverse engineering, they might be reversing malware. So they might be looking into how this particular malware is made. They might be looking at ransomware. Ransomware could be very dangerous if it gets out. So once everything is on the machines and in place for the students, we will sandbox them in. We won't let them have internet access. Any precautions that we can take. So these are some of the formal education courses that we do. Next, please. Now, some of the informal education. Informal education would apply to our clubs. So we have cyber interest groups inside of our Cyber Eagles student club. We have 3 groups. We have offense, defense, and CTF. CTF doesn't use the range as much because a lot of CTFs, they have their own websites, or they have their own files, and we don't want to just, copy, download, and put up things that already exist that are safe to use. So offense and defense use it the most. Offense, obviously, they work with some dangerous things. They might be hacking into a system that's set up to look like a hospital. They might be set up to look like a bank. They might be working with malware. They might be writing malware. Defense, they'll be defending from things like this. They'll be setting up environments with Active Directory, things you don't want to get out. They might be running DHCP servers, things that you don't want on a campus network. So they're all sandboxed in. And then occasionally we'll have offense and defense, play a tug of war type game where they'll, battle it out. Offense will try to hack into the defense machines, and then defense will defend. We also do a lot of competition training. This is very similar to the offense and defense group training, though. So some of the competitions that we do are CCDC, CPTC. We also train a bit for NCL, although NCL has their own thing. But some students have built in-house custom capture the flag events, and we'll use those on the range. Next, please. So research on the range. There's 2 of these projects that I'm extremely familiar with, and these are only some of the projects. NELMA and malware analysis. They may sound similar, but NELMA is, well, they don't sound similar yet. NELMA is an Android malware research project, and then malware analysis would apply to Linux or PC malware. Those 2 projects are the more containerized projects. They need to be sandboxed. These are projects that you would put on a range. We also do some CAN bus. We also have a CAN bus test bed, and then we also do work with PKI containers, so cryptography. And then we also have some network segmentation projects where they work with multiple routers, multiple network segments, and some of the data might be dangerous. So we want all of that sandboxed in their own little hole. NELMA, though, is one of the projects that it is containerized, but then some of the data, which is non-malicious, it's just a text file with some small data in it. It can actually be pushed out to another box on the range that then the range has a port connected to our high performance computer. Our range is not a HPC. It does not do high performance computing. So we do actually have a network segment that can send data over to the HPC. Next, please. So outreach is some of our more rapid deployment needs. Courses, they come once a semester. You might have labs that change. Some labs might stay the same, but outreach, you want fresh environments. You might have a different You might have a different game or engagement that you want the students to use. So some of the examples would be STEM Mobile, Gen Cyber, Cyber Discovery Day, and then WISIS. So STEM Mobile will gather a bunch of students into a semi trailer is what it is. It's been redecorated to be a technology education environment on wheels. Um, and then we will remote in to the cyber range using Raspberry Pis, and then they can play our CTF that we built. They can play other games that are other cybersecurity educational games. Gen Cyber is kind of the same thing, and then Cyber Discovery Day is also very similar. But normally we will have students at Tennessee Tech come in, and then we'll all connect to the range because of the pandemic and everything being remote now. We have had to change that up a bit, but we are using the range even more now because of this. WESIS, we've used the range once at the conference. This past year, before it got canceled, we were planning on using it very heavily. I was going to have to accommodate quite a few students remotely using the range. These are just some of the examples. Outreach is one of the more fun things to do on the range. Students love it. They get to play around. They can, kind of do whatever they want. It's not dangerous. There are rules, however, that you need to have in place with a range if you're going to have students, younger students, like middle school or high school. We do have web proxying set up on the range, so that I control, what they go to, what they look at. And then we do have rules. I mean, if you're going to be playing a CTF or doing an activity, these students might all be on the same network. You don't want some students that have some knowledge to be mean to other ones, and hack their machine, stuff like that. So you still need to take good care in how you treat the machines. You need to treat every machine like it's on an enterprise network or on a university network. But other than that, I mean, it is a lot safer to have them on the range. Next, please. So as far as expansion, this is just what we have in mind. So I want more automation to be built. We do have quite a bit, but I am apparently automating myself out of a job. But we want to focus on the kickoff of events and handoffs between our tools that we use. Currently, we have to babysit quite a few of them, and it needs to be a admin, so me or one of the senior students that is a developer on the project. So we only have 3 people really that understand how to kick off all this automation. I want to have a better user interface. That goes in, or that also applies to there only being 3 of us that know how to use it. There's good reason. It is all terminal based. There's a lot of things that you could do wrong because it is controlling the entire cluster of servers. So we're working on building a graphical user interface instead of having everything done manually or on the terminal. We also want better configuration management. This also requires a bit of babysitting. It's still faster, way faster than doing everything by hand or by copying everything over box by box, but it could be better. We would also like efficient queuing. So we want to do a queuing system so that in the case of there's so many projects on the range and we have all this automation, we have all this configuration, and we have a user interface that professors or whomever could use, what happens if we over allocate resources? Some projects might not get built. Some professors may wonder why their lab isn't stood up, and then I would get a lot of phone calls. So we want to be able to queue all of the events or all of the projects that are going to be built and do some sort of smart resource allocation. And we're also going to be adding additional server nodes. This one's kind of, I mean, it's kind of a no-brainer. We're just going to buy some more very similar servers and just throw them in a rack and then set them up on the cluster, and then we'll be good. Because right now we do use quite a bit of space. We use quite a bit of resources, mainly RAM. RAM is honestly the weakest thing. So if you do look into building a cyber range from scratch, um, CPU power does not matter as much as RAM does. You can get away with low storage. You can get away with a lot less CPU power than what we picked out. But if you only have, 256 gigabytes of RAM, you're not going to have room for a lot of machines. Some of these machines, Windows for instance, we try to allocate 4 gigs of RAM per machine. And then with Debian or Ubuntu, we try to allocate 2 gigs, or if it doesn't have a graphical user interface, we will try to knock that down to a gig or 512 just to save space. There's been a lot of times where I've had to migrate projects, half a project over to another server just to make up for space. It does get very busy. So next slide, please. And any questions? You can also, for any questions that we don't cover today, or if you think about it later, you're just like walking down the street and you're like, oh, I had a question. You can email us at CEROC@tntech.edu. You can also visit our website to find out more information about us or any events that we do.
Does
So
anyone have any questions?
yeah,
Yes.
I got a question.
Yeah.
Yeah. So how long did it take to develop the range? We've been developing the range for what, almost 3 years now. It's probably
3 years
going
now.
on 3.
Yes.
And it's a work in progress. We will be developing the range as long as we have the range.
We started the process in 2018 with one grant, one funded by us, and some experiments. And it's, as Dr. Siraj just mentioned, it is definitely a work in progress. We keep learning, we keep getting better at it, but it wasn't like we had the perfect design and, okay, here's a cyber range. It's been through experimentation and learning and feedback from our students and feedback from participants that have engaged in activities with the range.
So another question was how many people are working full-time on the range? So, we have only one tech full-time employee, that is Travis Lee, but Cyber Range is not the only thing he supports. CEROC has other infrastructure that's part of it, that's on his plate as well. Plus he's a grad student part-time as well. So what we have is, we have a couple of other students right now. We have 3 other students, undergraduate and graduate students, that work on the range as part of their research project, part of their graduate project, in different ways.
So will we be sharing any of our scripting tooling work publicly via GitHub or something similar? At some point, we may release some of the tools.
Yes. So as I mentioned, some of our students are working on this as part of their graduate work. So until they're done, we cannot do that. But, once they're done, we will review it. Do you have industry participation using the range or working with students and faculty? Not at this moment, but that's something that we are looking at doing in future, but not at this moment. Okay, so I guess there aren't any other questions. As we said, you can always reach us at CEROC@tntech.edu, and would love to share with you, how we did this and provide you advice on how you can do it if you're interested.
Some last minute stuff real quick. I do have a bit of advice for if any universities or places are trying to start out building the range, and this just refers to hardware. So we took a lot of help from Dell as far as what to get. We talked with them about what kind of deals were happening, things like that. They sell the hardware, so they should understand what their hardware can and cannot do. We also had a lot of help from someone in systems at Tennessee Tech. He is a vSphere administrator. But my recommendation would just be, if you want to go with Dell servers, talk to Dell. Find a Dell rep. If you already have a Dell rep as a university, talk to them. They're going to be able to help you out. They're going to be able to get you the best deals. Give them a budget. They'll work with it. That's what we had to do, and that's what we still currently do, is we talk to our Dell rep for everything.
And one of the other pieces of that too is just a lot of collaboration points around a lot of different groups on campus and off. I mean, Travis has mentioned that we're working with the vendors, but we've also spent a significant amount of time building relationships with our systems group, building relationships with our security office, and just trying overall to make sure that everybody knows what's going on. Everybody knows what the goal actually is, what we're trying to accomplish, and making sure they're on board. Because as you can imagine, some of the activities that we're engaged in could make your CISO very nervous. So you definitely want to include them in that conversation so that you kind of have a comprehensive view of, okay, this is kind of the goal. And overall, our CISO office has been very supportive. They have an appreciation for what it's going to take to educate these kids, because we need more folks in the pipeline. So they have been supportive in that regard. Our systems group has been very supportive in a lot of the technology or infrastructure aspect of it, the data center side of the world, where Travis jumps in and builds all the virtual pieces, all the virtual infrastructure in that role, in his role, and what he's been able to do. So be willing to talk, be willing to collaborate. That's the other part that has made this successful. And then just have a great group of students around that are willing to spend crazy amounts of time developing and trying and learning things.
Okay, I think that's thank you. Thank you for listening to us, and thank you for your time. So I guess we end here. I think that's the end of today's session at NIST.